Isang magandang araw sa ating lahat. So for today, I will be discussing the introduction to macromolecules. Okay, to start with, I'd like to introduce to you the polymers. So the basic definition of polymers is from the Greek word poly means many and merons means part or a unit. So, according to IUPAC definition of polymers, these are a substance composed of macromolecules. Pag sinabi din kasi nating macromolecules, polymer din yun. Okay. So, it includes substances from synthetic to natural biopolymers. When we say synthetic, these are industrially produced substances consisting of number of molecules linked together with a covalent bond. Ano ba yung covalent bond? Napag-aralan natin when we were in college or in a chemistry class that pag sinabi natin covalent bonding is sharing. Hindi yun yung transferring of electrons. Sharing of electrons ito. So, there will be a sharing of electrons between two atoms. So, yun yung sinasabi nating covalent bond. Example of these are plastics, synthetic fibers such as synthetic rubber. So, pag sinabi din nating polymer, polymers are made from smaller repeating units that are all linked together. So, natural biopolymers includes protein, the carbohydrates, the lipid, and the nucleic acid. So, in our biochemistry class, ang tawag natin dito is biomolecules. Okay, yung proteins kasi natin are polymers of amino acid, kaya tinatawag nating amino acid is the alphabet of protein. So, yung carbohydrates, the polymers of sugars are carbohydrates. The lipids is the polymers of lipid monomers. And nucleic acid can be DNA and RNA, the polymers of nucleotide. Okay, so polymers possesses unique physical properties such as flexibility and viscoelasticity. Ano ba yung ibig sabihin ng flexibility? In chemistry, when there are side chains or branches in the way, the polymer chains cannot slide over each other easily because there are more interactions between the chains. The chain with smaller plasticism molecules between them slip and slide over each other more easily. This makes the plastic more flexible. So kaya nagkakaroon ng flexibility ang isang polymer. So while viscoelasticity is one important characteristics of polymer materials, in their viscoelastic behavior. This means that polymer is elastic because after strain due to the application of stress, it is capable to recover. On the other hand, polymers are viscous because their capability to creep over the strain. Okay, so let us define polymer based on the two scientists. Okay, so 1833 coined by Johannes Jacob Berzelius. It was first introduced in 1833 by Swedish chemist Johannes Jacob Berzelius, defined as polis means many and meros meaning part. Ganun din yung definition natin kanina. Conducted pioneering experiment in electrochemistry and established the law of constant proportion. He contradicts the hypothesis of Dalton's that atoms are indivisible. Okay, so siya kinontra niya yung Dalton's theory that atoms are indivisible. So sa kanya, divisible daw ang atom. So yun si Johannes Jacob Berzelius. The other one during the 1920s is the modern definition of the polymers according to Hermann Staudinger is that he also presented reactions that form high molecular weight molecules by linking together a large number of small molecules. During this reaction, which he called polymerization, individual repeating units are joined together by covalent bond. Yan yung dalawang definition on polymer. Let us discuss now the history. of polymers. Okay, let us discuss now the polymers. Okay. It was all started during the 1284 that Horne's Company of London recorded use of horn and tortoise shell as the predominant early natural plastics. Okay, so as the natural plastic. Ancient Mesoamericans were the first people to invent rubber balls. Okay, sometimes before 16 BCE and used them in the variety of roles. British explorers discovered Mayan civilization to be among the first to find application for playing with the balls from the rubber trees. Yun nga yung sinasabi during the early 1500s. Okay. So, ancient rubber was made from latex of the rubber tree or the Castilla elastica, which is indigenous to the tropical areas of southern Mexico and Central America. Ang tanong natin, how do you get rubber from a rubber tree? Natural rubber tree is extracted by method called tapping, by making incisions into the bark and collecting the fluid into vessel attached to the rubber trees. The liquid is a sticky, milky sap called latex and requires a couple of steps before it will be sold as rubber tree. So the question was, how do you process natural rubber? Processing of natural rubber involves the addition of dilute acids such as formic acid. The coagulated rubber is then rolled to remove excess water and then rolling the latex into thin sheets. Some of the most common rubber manufacturing processes are extrusion, latex dipping, molding, and calendering. Extrusion begins with an unvulcanized compound being fed into an extruder. Once it's inside the extruder, it gets carried forward to a die, which is a specialized manufacturing tool used to shape the rubber. Okay, so now, let's move on to 1823. The Macintosh uses rubber gum to waterproof cotton. Okay, in 1823, Macintosh patented his new process by sandwiching a layer of liquid rubber made with naphtha between two layers of fabric. Macintosh had created a new material that would be resistant to water while also remaining flexible and wearable. Okay, so ito yung nakikita natin ng mga raincoats ngayon. Kaya waterproof siya because it is contains sandwiching layer of liquid rubber and two layers of fabric. Kaya ang tawag dito is Macintoshish, ganun. During the 1838, okay, a French Academy assessment of Anselm Payens, okay, kaya A. Payen yun identifies a compound extracted from a wood which he names cellulose. Okay, ang pangalan niya is Anselm Payens. Okay, so his research on ligneous matter, the then current term for the combination of lignin and cellulose that form the woody cell walls of trees and other plants. Okay, Payen reported that igneous matter, ligneous rather, then considered a single substance, contained two chemically distinct materials. One of these, the French chemist declared, had the same chemical composition as starch, but differed in structure and properties. Whether Payen himself named the substance cellulose is uncertain. So, una niyang na-discover to during the 1838, pero hindi pa siya ganun ka-sure about dun sa ano. Kasi, nung magkaroon siya ng experimentation about cellulose, ang una niya nakita is somewhat like starch. Although, starch and cellulose are both polysaccharides, pero yung isa kasi is depending on the structure okay, yung isa polysaccharide coming from polysaccharide na water soluble, yung isa is water soluble. Okay, the next one is all about, okay, we have made mention about the cellulose during the 1838. Okay, so Okay, then we have also the Celluloid by Hyatt Manufacturing Company. So, okay, so sa celluloid is made from a mixture of chemicals such as nitrocellulose, camphor, alcohol, as well as the colorant and fillers depending on the desired product. The first step is transforming raw cellulose into nitrocellulose by conducting a nitration reaction. What does celluloid means? Ito yon during the 1870. Is a tough, highly flammable substance consisting essentially of nitrocellulose and camphor. Once used in the manufacture of motion picture and X-ray film, it is now used in a limited line of other products including guitar picks, musical instruments, and table tennis balls. Okay. During the 1912, cellophane was discovered. Ano ba yung cellophane? Cellophane is a thin, transparent sheet made of generated cellulose. Its low permeability to air, oils, greases, bacteria, and water makes it useful for food packaging. And then it was followed by during the 1920, so na-discuss na natin yung discussion ni Hermann Staudinger that polymers are poly or many and mer is meros. Okay, and during the 1992, it was first chemically synthesized cellulose by Kobayashi and Shoda. So yung ating cellulose was first chemically synthesized by these two scientists. Okay. Okay, do. So, we have, during the 1839, okay, during the 1839, so vulcanization is a process that allows rubber to withstand heat and cold, revolutionize. Okay, so nagkakaroon tayo ng, it was coined by Goodyear. Okay, a rubber industry in the mid-1800, ito na nga yun. Automobile tires, pencil eraser, life jacket, balls, gloves, and more are all in a commercialized use because of Goodyear's relentless experimentation to unlock the molecular structure of rubber during the 1839. During the 1844, so nakareceive na siya doon ng patent, siya ang nakagawa kasi nung una na yon ng polymerization ng rubber, and then na-patent niya yun during the 1844, and the Goodyear Tire and Rubber Company was founded during the 1898. Next one. Okay, so during the 1845, okay, the Guccia-Percha Company was established in 1845 and made chessmen, mirror surrounds tea trays, commemorative plaques, animal figures, inkstand, and even a full-size board, among many other decorative items. Industrial products included machinery belts, acid tanks linings, and tubes. The extrusion machinery used to make the tubes model, it is said, on Italian pasta machine was soon adapted for use in wire covering. This technique was used first to insulate landline cables and later for submarine cables. Gutta percha is the gum of the tree native to the Malay Peninsula and Malaysia. At that time, there was no application for the material as cable insulation. This would come later. Unlike India rubber, which must be vulcanized to be useful as an insulator, yung bang umaano, yung tumatakip, yung nag-embrace dun sa inyong, for instance, sa inyong sa wiring, okay? So gutta percha is thermoplastic, softening at elevated temperatures and returning to its solid form at its cools. This made it easy to mold gutta percha into many decorative and functional objects, either by pressing the heated material into cold molds or by extrusion. Okay, so during the 1846, during the 1846, okay, cellulose nitrate was synthesized by Schoenbein. Okay, because he believed it is to be a nitro compound instead of ester of nitric acid, mistakenly called it nitrocellulose. Okay, so during the 1850, the first submarine telegraph capable in gutta percha. So, yun. So, ginamit pa rin ang gutta percha in the first submarine telegraph cable. Next one is your okay, the next one is June 1924 and also changed to rayon. So, Louis Marie Hilaire Virgo to the Grand and the Chardonnay. Okay, so ito yun, the Chardonnay. Okay, so he is a French engineer and industrialist from Besançon and inventor of artificial silk. Okay, kaya tinawag siya ng father of rayon. So, Chardonnay was working with Louis Pasteur on a remedy to the epidemic that was destroying French silkworms. Failure to clean up a spill in the dark room resulted in Chardonnay's discovery of nitrocellulose as a potential replacement to real silk. Realizing the value of such a discovery, Chardonnay began to develop his new product. Yun nga yung ating artificial zinc. He called his new invention Chardonnay silk, or Joie de Chardonnay, and displayed it in the Paris exhibition in 1889. And unfortunately, Chardonnay's material was extremely flammable and was subsequently replaced with other, more stable material. Okay, so yun yung silk during sa Chardonnay period. During the 1866, okay, so discovery of the polystyrene by Berthelot. Okay, so polystyrene is a synthetic aromatic hydrocarbon polymer made from a monomer known as styrene. Polystyrene can be solid or foamed. General purpose polystyrene is clear, hard, and rather brittle. It is an inexpensive resin per unit weight. It is a rather poor barrier to an oxygen and water vapor and has a relatively low melting point. Polystyrene is one of the most widely used plastics, the scale of its production being several million tons per year. Polystyrene can be naturally transparent, but can be colored with colorants. Uses include protective packaging, such as packaging peanuts in the jewel cases, used for storage of optical discs such as CDs and occasionally DVDs. Containers, lids, bottles, trays, tumblers, disposable cutlery, and in the making of models. As a thermoplastic polymer, polystyrene is a solid state at room temperature, but flows in heated about 100 degrees centigrade. Its glass transition temperature, it becomes a rigid again when cooled. This temperature behavior is exploited for extrusion, as in styrofoam, and also for molding and vacuum forming, since it can be cast into molds with fine detail. Okay, the next one is show thermoforming introduced shoes to make babies rattle from cellulose nitrate during the 1890. Ano ba yung thermoforming? Thermoforming is one of the oldest and simplest plastic forming processes. Baby rattles and teething rings were thermoformed in the 1800s or 1890s using one of the earliest cellulose-based plastics. The process saw major growth in the 1930s with the development of the first world-fed thermoforming machines in Europe. In 1898, so this is the beginning of mass production of RPM, gramophone records from shellac. And a flat disc record made between 1898 and the late 1950s and playing at a speed around 78 revolutions per minute is called a 78 by collectors. The material of which with this was made and with which they were coated were also various. Shellac eventually became the commonest material. Generally, 78s are made of a brittle material which uses a shellac resins. Okay, during the 1898. So, yan yung production ng ating gramophone records from shellac. Okay. So, during the 1910, okay, so there is an industrial preparation of bakelite. Okay, so dyan nagsisimula yung paggawa ng bakelite. Okay, so during the 1916, meron tayong bakelite issues in Rolls-Royce. Okay, so ginamit siya ng Rolls-Royce. And during the 1907 and 1910 rather, okay, so gumamit tayo ng vinyl chloride. So this is the history during that time, during the 1907, the 1899 Kirsch and Spitter in Germany and awarded patent for casting in plastics from milk. So nakagawa tayo ng plastic from yung sa milk. And then we have the stocking made of viscose begin to manufacture in Germany. So kaya tinawag na yung viscose yun, yung ano kasi flowy during that time, during the 1910. During the 1924, Rossiter at BT Cyanide developed urea, thiourea, formaldehyde resins, subsequently commercialized as the first water-white transparent thermosetting molding water. The next one is, during the 1925 confirmation of the macromolecular theory, he succeeds in measuring the molar mass of polymer by ultracentrifugation. So, yun yung development during the 1925, yung ultracentrifugation. The next one is your 1926 is nakadevelop naman tayo ng modern plastic injection molding machine. And during the 1927, large-scale production of vinyl chloride resins begin. Ano ba yung vinyl chloride? Okay, vinyl chloride is a colorless flammable gas that evaporates very quickly. It used to make polyvinyl chloride or the PVC pipes, wire coatings, vehicle upholstery, and plastic kitchenware. Higher than normal levels of vinyl chloride may be present inside the new cars as the chemical evaporates from new vinyl products. Again, nagkaroon tayo during the 1927 yung large production of vinyl chlorides. So let us now move on to the plastics as an industry. So kaya medyo ano tayo ngayon marami na tayong problema kasi ang dami na nating production ng plastic sa environment. So non-biodegradable naman ito. So marami sabi na ang tagal dito bago mawala sa ating environment, plastic as an industry. Okay. During the 1937, Colombo and Perchetti in Italy produced first twin screw extruder machine. So during the 1937, first commercial production of polystyrene by Parben, Germany. The family of polyurethane is discovered by O. Bayer during the 1937. During the 1938, first synthetic polyamides or the nylons produced by W. Carothers. The first commercial production of polyethylene in UK by ICI. During the 1936, aircraft canopies made from Perpex. And during the 1935, Tro-ester produced first extruded design for thermoplastics. And the 1932 is grouper plastic isolation or plastic acetone in injection molding patented. So, plastic in wars. Ito na. So, self-explanatory naman itong ating slide that during the 1940 up to 1943, nagkaroon tayo ng kung paano nagkaroon ng industry doon sa ating paggawa ng polymers. So, eventually nagkaroon tayo ng PTFT to be marketed after the trademark Teflon. So yun na nga yun. So yung Teflon yung inaano natin. 1943 yun. Okay, so this is also self-explanatory. Okay, so let us now discuss the high-performance plastics. Okay, so in modern industry, performance is a must. 'Di ba? So, we are talking about plastic here eh. So, kailangan natin maganda ang performance. It can cover many aspects concerning quality, efficiency, durability, speed, throughput rather, or resistance to external factors. The aim is to have application that runs smoothly with minimum maintenance and the best cost to performance ratio within our material portfolio. You will certainly find in high performance plastic you need for your application. So that is the importance of high performance plastic. Base doon sa ating history, so nagkaroon tayo ng uh, nag-evolve na yung production ng plastics. So, kaya nagkaroon tayo ng high-performance plastic now na ginagamit natin. The problem now is that ang dami-dami ng production ng plastic. So, ang environment natin ang nagiging napupulyot, kung baga. So, sabi nga, pag sinabi natin chemistry, yung tagagawa ng pollution. So kaya meron tayong sinasabi ng mga environmentalists, sila yung gumagawa ng paraan para ma-minimize itong pollution na ito. Okay. So again, ano pa rin tayo sa production ng high performance plastic during the 1980 and 1986. Ito po ang ating mga contributors in the production of high performance plastics. Okay? Okay, sila po ang nagbigay ng mga ng production ng plastic sa atin, yung mga high performance plastic. Hanggang 1998. Okay. So, ngayon we're talking about nanotechnology. So, ano ba ang nanotechnology? Pag sinabi daw nating nanotechnology applied to polymers and composite applications, yung Polymer Nanotechnology Group will develop enabling techniques for the patterning of functional surfaces. Nanotechnology has made important contribution to the formulation of adhesives, sealants, coating, patting, and encapsulation compound. So, iyan po yung tinatawag nating nanotechnology applied to polymer and composite application. So, naririnig na po natin yan. Nasa 2000 na po tayo. Ibig sabihin nun ina-apply na natin yung nanotechnology natin sa application din ng paggawa ng mga polymers. Ano po ba ang mga polymeric nanoparticles or the PNP? So these are defined as submicron, 1 to 1,000 nanometers colloidal particles comprising active pharmaceutical ingredients encapsulated within or absorbed to macromolecular substances. So, saan natin madalas nakikita ang nanopolymers na ito? Okay, so normally, nanoparticles can be used in a drug delivery system. Okay, so it can be a chitosan, an alginate, and xanthan gum, cellulose, liposomes, polymeric micelles, dendramers, and inorganic nanoparticles. Yan po. Okay, so yun na po yung ating history ng ating polymers.